Hey everybody, welcome to semester 2, day 3 of summer school geometry. Today we're talking all about the Pythagorean theorem, and I'm going to kind of show you some things that you may not have realized before that you were doing, but you were actually using these things in math. What I'm going to be talking about in this first box is the Pythagorean theorem is actually the same thing as the distance formula that you learned earlier in semester 1. So now the distance formula, if in case you need a refresher on what that is, the distance formula, that's the distance formula right there. So what I'm going to do in this first box is show you how the Pythagorean theorem is the same thing as the distance formula, okay? Now, I'm going to put in an example because Pythagorean theorem is usually used in application problems to figure out real world solutions. So what I'm going to do here is I'm going to pretend that there's one person. If we're looking at a map from a bird's eye view, let's say that there's one person standing over here in this corner of this triangle. And then we got this other person standing in this corner of the triangle. Okay, so we have this right triangle. We have the two people standing at these opposite ends of the hypotenuse. And what I want to do is, since we're in COVID right now, we're learning about social distancing. What I want to check is, are these two people following the rules for social distancing? They're out in public, they need to stay 6 feet apart. So I need to check, is this length of the hypotenuse 6 feet or not? Is it more or less than 6 feet? What exactly is this distance here? That's what we're trying to figure out. So what I can do is, the quick way that you would probably assume to do this is Pythagorean theorem. And what you can do is look at these coordinates and determine what are the length of both of these sides, the legs of the triangle, the right triangle. So if this is at coordinate 2, 3, and this is at 5, 3, then we're thinking about the length here. That's the x values, the change in the x, which is the difference between 5 and 2. So this distance is 3. Because to get from 2 to 5 on the coordinate plane, you need to go 3 units. And if I want to check out this distance here, this distance right here from the corner up to this person would be the difference between the y values, 9 and 3. The difference between 9 and 3 is 6. So automatically, most likely, I know that these two people are social distancing if we're talking about feet here. This is 6 and this is 3. So by Pythagorean theorem, this is going to be more than 6 feet because this is already 6 feet. This line has to be more than that. But what we can do now is we can figure out the distance. So the distance is equal to, and we use Pythagorean theorem, so we would just follow the normal rules that we know. 3 squared plus 6 squared equals the distance squared. I'll just use the letter D here though, distance squared. And I would just solve that out by the Pythagorean theorem. So now what I'm going to do is I'm going to show you the same exact thing using the distance formula. It's the same exact thing. We ended up actually doing that work in the Pythagorean theorem itself when we figured out 3 and 6. So right here I had the distance formula that we set up and we learned earlier in the first semester. Here we have x2 minus x1. So I'm trying to figure out the distance between these two guys right here, right? So let's say that we had x2 minus x1. What's 5 minus 2? So I'm going to put that in right here, 5 minus 2, and I'll put a squared there because I have x2 minus x1 squared, plus y2 minus y1. What's 9 minus 3? 9 minus 3 is just 6. So I'll put that right here, 9 minus 3 squared. We still need that big square root to go over everything, just like we started off in the formula. And we have d equals all of that. Well, if I just start doing the math here, this looks exactly like this right here. 5 minus 2 is 3 squared. 9 minus 3 is 6 squared equals d. I got the square root on top. Notice how we have 3 squared, 6 squared, 3 squared, 6 squared. I continue to do the problem. 9 plus 36 with the square root on top, 45 with the square root on top. D equals 45. Boom. Same exact thing. These two formulas are essentially the same thing. They just look different. They look different, but they're the same. We did the same thing with both of them. And so now you can kind of think, if I worked backwards from the distance formula, this is like a squared, x2 minus x1 is a squared plus b squared equals d, and where's the squared? Well, this thing is square rooted. So if I put the squared back over here, this square root goes away. So it ends up becoming the same exact thing as Pythagorean theorem. So that's what I kind of wanted to show you and make that connection in this video. Okay, on your Delta math problems today, it's going to be pretty straightforward on using the Pythagorean theorem. So for example, one problem might give you a missing side that you have to figure out. Well, in that case, we could just use the Pythagorean theorem. So I'll just write a squared plus b squared equals c squared. I don't know why I put x here. I'll put an a there just to represent the first side. A squared plus b squared. B is going to be 2. So I have a squared plus 2 squared equals, my hypotenuse is square root of 93 squared. So that's the setup for it, and you can go continue and solve the rest of it. You'd get a squared plus 4 is equal to, now here, square root of 93 times itself, square root goes away, we're just left with a 93. And if you need to confirm that on Desmos, feel free to do so. You just type in square root of whatever, and then put a squared on the outside of it. You notice you get a 93 right there. And then we have a squared is equal to, if I subtract 4, I get 89. So a is equal to root 89. Okay. Let's work another example. It says, which of the following sets of numbers, now a set of numbers is just a list, which of the following sets of numbers could represent the 3 sides of a right triangle? Meaning, if you have a right triangle, remember, it has to meet the requirements for the Pythagorean theorem. A squared plus b squared has to equal c squared for any right triangle. For any right triangle. So that means that we have to look at these sets of numbers and figure out which one of them would meet this criteria, would satisfy this equation. So what I could do is I could go into my calculator here, and let's check. I want the 2 shorter sides to be a and b. So in this first answer choice, I would check 32 squared plus 60 squared. So 32 squared plus 60 squared is equal to 4,624. And I would check the third number, the largest number, and I would square it, 67 squared. Those two should technically be equal to each other, but they're not for this one. So answer choice number 1 is incorrect. And I could go back and check the rest of my answer choices here. So let's try the next one. 14 squared plus 84 squared. And then I try, what's 85 squared? It's 7225, but I got 7252 for the first one. It's close, but it's not the same thing. So it can't be this one either. Okay, let's try the last two. I'll try 27 squared plus 36 squared, and then I'll do 45 squared. Okay, those two look like they're equal to each other. So it looks like this is my answer choice because I use the 2 shorter sides as a and b, and then c squared was right here. They both end up equaling the same thing. So this is my answer choice. Okay, and you could probably check the last one. It's not going to work. Okay, so that's how you would test out those types of problems, is just check which of the combinations worked. All right, and then there's problems where you have to set up the triangle, knowing which direction is which. So if you need a reference for the compass, northeast, southwest in clockwise order like that. Okay, so there's our compass. It says you're driving north for 21 miles. Okay, so I went north 21 miles. Then I said I turned right. And I drive east for 20 miles. So let me Draw this as best to scale as I can. Let's just say that's 20 miles. So this looks like that's a right angle. At the end of the driving, what's a straight line distance from your starting point? So starting point is this purple dot down here to the end point, the green one over here. So we need to figure out what this guy is. Pretty straightforward. Pythagorean theorem, 20 squared plus 21 squared equals c squared. I'll call this guy c. And then I just follow the steps for Pythagorean theorem, and I can simplify that down. Okay, so there's the examples for Pythagorean theorem. Go ahead and take a look at Canvas and Delta Math and see what problems you need to work on. As always, if you have any questions, please don't hesitate to reach out and ask me through email or through Canvas.